Alright, this is MAP4C day 18. This video, long 3-minute review, which hopefully you don't even need because you just get the answers. And short lesson. The short lesson is essentially just me setting you up with spreadsheets again. So let's get into it. The goal last day was to solve problems involving the surface area and volume of 3D shapes. It says a cooler will hold 60 liters. What is the minimum surface area if it is 3 different shapes? And then we'll talk about the best overall. And we know what these shapes are, right? So for A, for instance, if it's a rectangular prism, what's the best shape? It's a cube. We know that. And so all we need to do is figure out the dimensions of that should be a cube. Notice we need to go from liters to centimeters, centimeters cubed and then to centimeters. So let's do that. 60 liters is 60,000 milliliters, right? There's the, which each milliliter is a centimeter cubed, so that's 60,000 centimeters cubed. Okay, and draw a little diagram of our cube. Should be using a ruler, but oh well. Oops. X by X by X, right? And so here, the volume has to be 60,000. That means X cubed has got to be 60,000. How do I get X? Well, I got to do the cube root. Cube root of that number. Which is about 39.1. And then I can calculate the surface area, 6 squares, right? Surface area is 6x squared. We've done a few of these now. All squared. That goes into calculator and you get about 9,173 rounded centimeters squared. And that's the best rectangular prism. So that's the best cooler shape that's a box is going to have that surface area. Now, what happens if it's a cylinder? I'm going to change colors for the cylinder. Cylinder. Well, what do we know about a cylinder that's optimal? We talked about this last class. The idea is it's got to be the most cube-like cylinder. Well, what does that mean? It means that this diameter and this height is equal. Or another way to say that is the height is 2 radiuses. And that's kind of like a fact that we're going to remember just to get the best cylinder-shaped cooler. Well, what do we know? The volume of a cylinder is pi r squared h. Formula, you got that on your formula sheet, which you can use on the assessments coming up. The volume 60,000. Right, volume is 60,000. And we saw one like this last time, where what we can do is we can figure this out algebraically, because to get the best shape, I know the height has to be 2 radiuses, so instead of writing in h, I can write in 2r, and then work with the expression, right? Well, if I put r squared times r, that's r cubed, and I knew this was coming. I'm going to put the 2 and the pi together as the number part in front, 2 and the pi part in front, r cubed. Now, why did I do that? Eventually, I want to take the cube root so I can find out what the radius is, right? But I got to get rid of this first. How do I get rid of the 2 pi? Well, I divide by 2 pi on both sides. This is a little messy, but that's okay. That cancels. On this side I'm left with r cubed. And on this side, remember to put brackets on the bottom there to put that into your calculator. That's equal to about 95.49. Nice 5. 95.49.3. Take the cube root of that. Cube root. And you get about 21.2. Then the height is twice that, right? The height is twice that, 42.4. And then I can find the surface area. I'm kind of interested out of a cylinder or a cube, which is the best? Well, we're going to find out soon. And then straight off my formula sheet is where this is coming from. R we said was 21.2 squared plus 2, 21.2 times 42.4. Oops. 42.4. Then I would suggest putting that entire expression carefully into your calculator. All in one step. Don't press equals and have to write down some big, awful numbers. 84.71. Decimal 7, so I'm going to round to that to 2 centimeters. And there you go. Well, cube was 9,000 and change. Cylinder was 8,400. So far the cylinder is the best. Now what happens if it's a sphere? We don't see too many sphere-shaped coolers, so maybe would think that it's not a very good shape. As it turns out, and you could probably have guessed this, it ends up being the best. And why aren't there too many sphere-shaped coolers? Well, you could figure that out, right? Because they'd roll all over the place. The volume is 4 pi r cubed divided by 3. And we have, again, we want to take the cube root. We have to solve for r before we can take the cube root. So we got to get rid of all these other numbers. First thing I'm going to get rid of is this big divide sign. Divided by 3, I'm going to multiply by 3 on the other side. So that's 180,000 there. Again, got to get the r cubed alone before I can cube root it, so I'm dividing by 4 pi on both sides. And that's going to cancel out. On this side I'll have r cubed. This goes into a calculator. Watch your brackets again. And that's 14,323.9-ish. And then cube root that. Right, cube root of the answer. It's about 24.3 centimeters. It's not very big, actually, to hold a whole 60 liters. And then we got to figure out the surface area, right? So compared to the other two, surface area of a sphere. Got this on your formula sheet? I hope so. It just goes into your calculator. 24.3 there. And you get 74. 74. Darn, sorry, folks. Right there. There we go. 74.20.3. So I'm going to round off to the nearest centimeter squared. And it's way better, isn't it? The cube was 9,000 and change. Cylinder was 84 and change. 70, like 1,000 centimeters squared better. So the sphere is best. So if you had any shape to choose and to enclose something, the sphere is the best. And that kind of makes sense because when we talked about flat shapes, the circle was the best. So it kind of makes sense that the sphere would be the best. Now, sort of one of the last details to take care of today's lesson, and I'm not going to go through it very much, is this idea of optimizing volume and surface area using spreadsheets. We did some work a couple of days ago on optimizing perimeter and surface area using the spreadsheets, and this is just another chance to go through that. So again, I'm going to basically show you where remind you where the files are and let you go. Remember that one of the spreadsheets is required to mark for this unit, so do a good job. All right, so where are the files for this? Again, what I would do, open Office first, which looks something like this. Go into Open Office first, Spreadsheet. And then open the right file. And this one happened to be, hooked up to the last place where we opened stuff, so it went very fast. And I think the one that you start with is this surface area opt, SAOPT. I think is the one you want. Open it up. And then follow the instructions in the book. Again, we're going to be dragging some of this stuff down. All right. Notice that there's 3 investigations in this section, and you get from one to the other by clicking on the bottom tabs. Okay. So have fun. Do a good job. That's it.